All right, this is an example of the problem number 1 on week 8, problem set 7. And I'm going to give kind of a demonstration of how to use the extended Euclidean algorithm to solve 3 possible solutions. So what we're doing is we're taking this equation here, 61x equals 7 mod 126. And what that really is kind of saying is that we're trying to solve for an x here such that when I multiply it by 61 and then divide by 126, the remainder is 7. Now there could be multiples, there's an infinite number of solutions actually, but we're only looking for the 3 smallest positive ones. So to do that, we have to locate our first x and then go from there to find 2 more after that. So what we do is we start by just doing the straight Euclidean algorithm, and then later on we'll do the extended, but we do the Euclidean algorithm to solve for the GCD of 61 and 126 because those are the numbers that we're multiplying by and the mod that we are in. So to do that Euclidean algorithm, you can see the work that's right here. Once we get down to this level, we can kind of see that because our last multiple is 1, the GCD of 61 and 126 is 1. And this confirms that we have a unique least residue solution. So there's only one unique least residue solution between 0 and 126. Next, we have to solve for this, but before we do that, we need to find instead of it being 7 mod 126, we need to find what 1 mod 126 is. And by doing that, that allows us to find what the multiplicative inverse of 61 mod 126 is, and then we'll use that eventually down here to multiply through with both sides to get our least residue solution. So note that we can write 61 x equals 1 mod 126 as 61x equals 1 times 126k. This really just means I'm adding 1 to whatever multiple of 126 that I have. This is equivalent to if we move the 126k to the other side, like subtracting 126k. And if we replace the negative k with y, we have a linear congruence equation, and it looks like this. And this is what we're going to kind of start from to complete the rest of this. So the Euclidean algorithm above, we're going to use that to kind of plug stuff into each other to make it look like this linear congruence equation. So starting from this middle row above here in the Euclidean algorithm, we have 61 equals 4 times 15 plus 1. And if we rearrange that by subtracting the 4 times 51 to the other side, we have something that kind of looks like this, which can also be written with a negative inside of the 15. Doing that same thing to the top equation of 126 equals 61 times 2 plus 4, moving the 61 to the other side and then embedding that negative into the negative 2, we have that that's equal to 4. Now, with these two equations here, what we get for the first one and the second one, I see that there's a 4 located here in what is the result, and I see a 4 up here. And what we're going to actually do is, since this part right here is equal to 4, we're going to kind of stick him up inside of here using substitution. So you can kind of see how we did that here by substituting the 126 plus 61 times the negative 2 in for that 4. We can reduce that down, and it looks like this when we combine all of our like terms and everything. This 61, this row that starts with the 61, kind of looks similar to what this one is, and we can see that the x is equal to 31 and the y is equal to negative 15. Now, since our x is equal to 31, this means that our multiplicative inverse of 61 mod 126 is 31. So if we take now 61x equals 7 mod 126, which is what we're really interested in, and multiply both sides by 31, since 31 is the multiplicative inverse, it will get rid of the 61 on the left side to produce just x down here. So multiplying both sides by 31, gets rid of that 61 because they are multiplicative inverses. And 31 times 7 is 217 in mod 126, which actually reduced down, because you can subtract 126 from 217, is 91, and that is the least residue solution. So that's the unique least residue solution, and what we're trying to solve for to start with. To find the three smallest positive solutions, we would take 91 and add that to 126. So 217 would be our second least residue, or our second residue solution, and the third one would occur at 91 plus 2 times 126, or the third one is at 343. And there is your three solutions using the extended Euclidean algorithm to solve for the three smallest positive solutions of this equation.